Hello students, as I promised you in the last class that I will be discussing the application of thermal expansion, that is linear thermal expansion, in the following cases. That is in case of simple pendulum, that is in case of bimetallic strip, that is in case of thermal stress and scale problem. So let us begin one by one these aspects of the linear expansion. In fact, these are the side effects of the linear expansion. So let us discuss one by one. In simple pendulum, the detail will be taught to you in the mechanics section. Here I will only tell you that the time period of simple pendulum is given by t is equals to 2 pi root under L by G. In few years back, the watches use the pendulum clock. So this is the pendulum and this is known as bob, which is metallic, and from the center of the bob to the point of suspension the length is this L, that is the length of pendulum. Generally, this is of metallic rod, so the effect of temperature is there on this metallic rod, and in summer due to thermal expansion the length increases, whereas in winter the length decreases. So what we observe that due to temperature change the length changes, as length is related with time period, so time period also changes. Now two terms are there, one is small t and one is capital T. This t is basically constant for a periodic motion and this t is variable. So what I mean to say that if from here to here, if the bob is oscillating, then if we start from here to here to here to here, this will give you one time period, and it is generally constant for a periodic motion. So, and time is variable, this is continuously changing. So time period, if you start from here, it will be here, 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 or if you will start from here, it will be here, here. This makes one time period. And in the second spin pendulum that we use in case of your watch, the time period is your 2 seconds. 2 seconds is the time period of second pendulum. Now suppose if we talk about the temperature change, then this will not change, this will not change, this will not change, but this is going to change because this is temperature sensitive. And so if we take the value of time period, then time period T dash, that means when the temperature has changed, will become 2 pi root under L dash by G. What is L dash? L dash is the length of the simple pendulum when the temperature has changed. So in this situation, L dash is equals to L into 1 plus alpha delta T. As I have discussed this formula, that final length after temperature change, final length is initial length 1 plus alpha delta T, where delta T is the change in temperature and alpha is the coefficient of linear expansion. Here I am removing this delta T because here your T is there, it will make confusing. I am writing it as delta theta. So temperature change is your delta theta. So delta theta represents your temperature change. Now alpha, as you understand, it is coefficient of linear expansion, and this is the final length after the temperature has changed, and this in fact is your initial length. Now you try to understand that this is the time period of simple pendulum and this is the time period of simple pendulum after temperature change. Now what I would like to tell you, that if in t dash 2 pi, I am putting the value of L dash. So what is this? L 1 plus alpha delta theta by G under root. This value we are getting. If I write it in this way, 2 pi L by G under root into 1 plus alpha delta theta under root. It can be written in this way. Now next what I would like to tell you, this value you already know that it is the original time period. So I am writing it as t 1 plus alpha delta theta whole to the power 1 by 2. Here root is there, so we can write it as 1 by 2. Now I will be using the binomial approximation. So what is binomial approximation? Binomial approximation is basically 1 plus x whole to the power n is approximately equal to 1 plus nx. Here the condition is x should be less than equal to 1. So this is the binomial approximation that we have to use here. This matter I have taken from mathematics. This mathematics will help you in making the physics simpler. So if I will use here, this exponent will become coefficient, and you are getting t into 1 plus 1 by 2 alpha delta theta. This is the value of new time period after the temperature change. And if I can remove the bracket, you are getting in this way. So if we take it to LHS, then t dash minus t, this is giving you, so t dash minus t is what? This is change, and if I divide it by t, this is the formula that you are supposed to remember all the time for the loss or gain in time. What I mean to say, this is the loss or gain in time per second. So if I want loss or gain in time delta t, small t I am writing, then it should be 1 by 2 alpha delta theta into t. Now this t can be your 1 hour, 1 day, whatever value you can put here. So this is the loss of time, loss or gain of time, delta t 1 by 2 alpha coefficient of linear expansion, and this t for day. If t is equals to 1 day, then in second you can write 1 into 24 into 60 into 60, and that will give you 96400 second. So this should also you should remember. So this is loss or gain in time. Now the question arises, what does it mean by loss or gain in time? Loss or gain in time means that if we talk about summer, if we are talking about summer, this length will increase, this time period will increase. So the pendulum which was taking 2 seconds, now it will take more than 2 seconds. So more than 2 seconds means the clock will become slow, and the clock will become slow, it means it will lose time. Clock will become slow. So you should understand, in summer the value of time period increases. This time period increases means loss in time, and at the same time you can understand that watch becomes slow. So in summer, the time period increases. Time period increases means loss in time. It should take 2 seconds, but it will take, suppose for example, 2.2 seconds. So there is loss in time, and when there is loss in time, then the clock will become slow. And just in the reverse case, in winter we will get time period will decrease. Why time period will decrease? Because this length will decrease, so this L will decrease, so time period will decrease. That means this 2 second will become 1.8 second or 1.9 second, for example. Then we will say it as gain in time. And if it is gain in time, the watch becomes fast. So you should understand it very carefully. What does it mean by loss in time or gain in time? That should be also mentioned. In question it will be mentioned that you have to find loss in time in 1 hour, in 2 hour or 3 hour or 1 day or 12 day, whatever value they can give here. So this is the master formula, standard result, which you are supposed to remember all the time, that loss or gain in time, this value you have to remember. I am keeping it in the cloud. Loss or gain of time should be represented by this value. This is standard result, you should remember all the time. Now what I will do, I will do one question on loss in time and one question on gain in time on the same concept. So we shall be basically applying this concept by using this formula. Now see the problem. A pendulum clock consists of a thin iron rod connected to a small heavy bob. If it is designed to keep the correct time at 20 degrees centigrade, the pendulum is designed to give correct time at 20 degrees centigrade. How much fast or slow will it go in 24 hours at 40 degrees centigrade? So naturally the temperature is increasing, so it is the case of summer. And summer means loss in time. So it is the case of loss in time. And means the clock will become slow. So the data is given: initial temperature, final temperature, and the time. Now, as I told you in our standard result, that loss or gain in time, this factor is given by 1/2 alpha delta theta into t. This is the time. Which time? 24 hour. Change in temperature is how much? 40 degree, 20 degree. Alpha value is given in the question. So first of all, you should understand that what are given in the question and what you have to find. So given in the question, change in temperature, the time, the alpha, and then the working formula is this, which I have shown you as the standard results. So delta t is equals to 1/2 alpha delta theta t. This t is what? This is 24 hour. So 1/2 into alpha, 1.2 into 10 to the power minus 5. Change in temperature, 40 minus 20 into time, 1 day. 1 day, that means it is telling about 24 hours. So 24 hours in second is how much? 86400. And by calculation, you will be able in getting the result 10.36 second. So the clock will become slow. In 24 hours, it will become slow by this amount. As I told you, it is the case of summer where there is a loss in time, and when there is loss in time, the clock will become slow. So this is the question that is directly based on the application of linear expansion used in the case of your simple pendulum. Now see this question. The second example that I am going to discuss with you, here the pendulum clock is there and keeps correct time at 30 degrees centigrade, has a pendulum of iron. how many seconds will it gain or lose per day when temperature falls to 0 degree centigrade? Here the coefficient of linear expansion alpha iron is given 12 into 10 to the power minus 6. Now first thing that you should immediately understand that here the temperature is 30 degrees centigrade and here the temperature goes to 0 degrees centigrade. So it is the case of your winter. It is the case of your winter. Temperature is going down. When temperature is going down, winter case means gain in time. Gain in time. And gain in time means the clock will become fast. Now the standard result, as I told you in the previous question, delta t 1 by 2 alpha delta theta into t. 1 by 2 is there, alpha is there, delta theta is 30. From this temperature to this temperature range is 30, and the time per day. This per day means 1 day, and this day is your 86400 second, and ultimately by calculation you will get that it will come 15.55 second, and this much is the what? Gain in time or loss in time? It is gain in time. Why? Because it is the case of winter, and so the clock will become fast by this amount, as it is the case of winter. So we have understood the application of linear expansion in case of your simple pendulum, which is very important for your board examination also and for your entrance examination also. In board examination, in entrance examination, only slight difference is there. Manipulation of data is there. The data is given in such a way that you will be doing the calculation in a comfortable way if clarity of concept is there with you. So these two examples I hope will help you in understanding the concept of linear expansion applied to the simple pendulum. Now we will apply the concept of linear expansion in the second case, that is bimetallic strip. So let us talk about bimetallic strip. In bimetallic strip, as you all understand that there should be two metals whose coefficient of linear expansion is different. So length remains the same. Length is also this one, and here it is alpha 1, here it is alpha 2. So alpha 1 is the coefficient of linear expansion of rod 1, upper rod, and alpha 2 is the coefficient of linear expansion of the lower rod. As alpha 1 and alpha 2 is different, if we increase the temperature, this rod will, and it is attached. Here it is attached, it is fixed in a proper way. So this thickness is also D and this thickness is also D. If we consider alpha 1 is greater than alpha 2, then see what will happen. There will be more expansion in upper rod and there will be less expansion in lower rod. So in this situation, what you will observe, that the situation will convert into this way. This is the upper rod with alpha 1 and this is the lower rod with alpha 2. Now try to understand in this situation whose alpha is more, that will go into the convex side because here the expansion is more. In this case you will see that the expansion is more in this case. Now here the very important concept comes, that is in this way, that if we take the center of this arc, then you see this tells about the radius and I want to find this radius. This will be your D by 2 and at the same time from middle this, and from this side if you will take this side, this will also become D by 2 because this is D, this is D. I am taking this middle line. I am taking this middle line. So this distance and this distance from here, it becomes d by 2. It becomes d by 2. If I take this as the radius, then this value will become r minus d by 2. See here, this is r, this distance is d by 2, so this distance is r minus this distance, that is total distance r minus d by 2. And if we consider this distance, you see here, upper, up to this it is r and plus this d by 2. So r plus d by 2. So this will become your r plus d by 2. And if we consider this angle as theta, then I want an expression of this radius r. That what is the expression for the radius r, because it will reveal many hidden facts about this bimetallic strip. So try to understand that what will be the value of r. Here the initial length, we already know both rod have initial length L. Next thing is there to understand that in order to find the value of r, I will like to use the relation from mathematics. Angle theta is equals to arc by radius. So arc is equals to theta into radius. Why I am interested in arc? Because this arc will give the final length of upper rod and this arc will give the final length of lower rod. So if I use the arc by radius relation for upper rod, final length L final upper rod is equals to initial length L into 1 plus alpha, temperature change remains same, delta theta. Now what is this final length? Final length from here is arc by radius. Is final length is theta into radius. Here the delta theta is temperature and here I am talking about the angle. So this theta into radius, theta is your, theta into radius is what? Radius is your r plus d by 2. R plus d by 2. This value you are getting L into 1 plus alpha delta theta. Don't confuse. Here this theta is angle. Here this theta delta theta is change in temperature. Now take it as equation number 1 for upper rod. If we talk for the lower rod, for lower rod, length final is equals to L into 1 plus, here you see upper rod I have taken, so it should be alpha 1, and for lower rod 1 plus alpha 2 delta theta. For lower rod the coefficient of linear expansion is alpha 2, so here it is alpha 1 and here it is alpha 2. And what is the length final of the lower rod? It will be arc will be the final length will be theta into radius, theta remains the same, into radius is your r minus d by 2 is equals to L into 1 plus alpha 2 delta theta. This is we are considering about the second rod. So first rod final length we have calculated and then we have applied theta is equals to arc by radius concept, and then this term is giving the final length by this relation, theta is equals to arc is equals to theta into radius. Now little bit mathematics I will be doing in order to get the value of r. So what I am doing, I am dividing 1 by 2. So 1 divided by 2 this will give you theta, theta will cancel, r plus d by 2 by r minus d by 2 is equals to L will cancel, 1 plus alpha 1 delta theta by 1 plus alpha 2 delta theta. This value we have got by dividing equation 1 with equation 2. So we are getting this relation. When we have got this relation, then certain more mathematics is required in order to understand this concept. What is that mathematics? That I would like to tell you that in that mathematics we have to understand the concept of componendo and dividendo. Componendo and dividendo. Componendo and dividendo you have read in your junior classes. Componendo and dividendo you have read in your junior classes, and you know that if A by B is equals to C by D, then by componendo and dividendo A plus B by A minus B must be equals to C plus D by C minus D. This result is being called as your componendo dividendo. So if the ratio is there, here also A by B is equals to C by D. So I will apply the same concept of componendo dividendo here, and then we will be in a situation to understand and derive an expression for the radius. So what I would like to tell you, now we will have to apply the concept of componendo and dividendo in the relation this one. So in this relation we are going to apply the concept of componendo dividendo. So what will be there? This is A, this is B. So by componendo and dividendo, what we are getting? We are getting r plus d by 2 plus r minus d by 2 by r plus d by 2 minus r minus d by 2. This is in this side. Similarly, we will apply componendo dividendo in second side in RHS. What will be the result? Result will be 1 plus alpha 1 delta theta plus 1 plus alpha 2 delta theta by 1 plus alpha 1 delta theta minus 1 plus alpha 2 delta theta. This is after componendo dividendo. Now when we have applied this componendo and dividendo, see, something will cancel. This d by 2 will cancel. Here if we will remove the bracket, r will cancel. This will become plus. So what finally we are getting? We are getting r plus r 2r by d by 2 and d by 2 plus, that will become d. So we are getting here 1 plus 1 2 plus alpha 1 plus alpha 2 into delta theta by 1 minus 1 will cancel, alpha 1 minus alpha 2, alpha 1 minus alpha 2, and then delta theta. So this is the final result that we are getting. The final result in this way, where d is given, alpha 1 is given. But for further simplification, what I will tell you, alpha 1 and alpha 2 are in numerator and they have got a value of the order of 10 to the power minus 6. So this sum will be very small, and therefore we can neglect this term. This term is very small, so neglected. This term is very small, so it is neglected. And when it is neglected, we can understand that the simplified version of this same result will come in this way. 2r by d must be equals to 2 by alpha 1 minus alpha 2 into delta theta. So 2 will cancel, and we are getting the final result r is equals to d by alpha 1 minus alpha 2 into delta theta. This is the standard result which you are supposed to remember all the time. For many times in the entrance examination, in the competitive examination, this question has been asked that how r depends upon alpha 1, alpha 2, delta theta and d. That means if we understand it properly, then r is proportional to d. What does it mean? If the thickness is more, r will be more. Second thing is there, if r is proportional to 1 by alpha 1 minus alpha 2. What does it mean? That if alpha 1 minus alpha 2 difference is large, value will be a small. If this difference is a small, value will be large. And finally, we get that r is proportional to 1 by delta theta. If the temperature change, that means if the difference in the initial temperature and final temperature is more, this value will be less. And if this value is less, this value will be more. So this result is very important for your entrance point of view, and you should understand it very carefully by practicing 2 or 3 times, so that you feel comfortable. If the question is being asked, then you should give the answer keeping this formula in mind. And this is the radius, that common radius we have got here. This is the radius that we are getting here, which is the part of upper rod also and lower rod also. This distance is basically the radius that I am talking about, this one. So I hope that this much discussion of the bimetallic strip, and it has got varieties of uses also. But bimetallic strip, the concept will be clarified to you, and we have applied the same concept of linear expansion in the bimetallic strip. So this bimetallic strip concept should be clearly understood by you people as an application of thermal expansion. Application of thermal expansion, in fact linear thermal expansion. Now we will try to understand the third concept of thermal expansion, linear thermal expansion, that is being used in your thermal stress. This stress word will be taught to you in detail in elasticity. Here you should understand that stress is dimensionally equal to pressure. It is not pressure, but in dimension terms it is equals to pressure. And then we can say it is force by area and unit Newton per meter square. This thing you should understand about the stress. That stress will be taught to you in mechanics in detail in the elasticity portion, and there you will understand that it is your dimensionally equal to pressure. One term is there that we call a strain. A strain is basically change in length by original length, and this strain is unitless and dimensionless. What is a strain? If a wire is hanging here and its initial length is L, and we apply a force, we put a load here, suppose in this way, then its length has increased. Under the load, the length will increase, and suppose it has become in this way. Same wire has got under the load condition in this way. So this is the change in length, and this is your original length. So change in length by original length, in physics it is defined as a term which has got the name strain. So stress is one term and strain is another term. Now one more term I would like to introduce, and that is Hooke's law, which will be discussed with you in the elasticity section, where it will talk about elastic limit, that what is elastic limit, and within elastic limit it is found that a stress is proportional to a strain. A stress is proportional to a strain. Now a stress is of different types, a strain is of different types. I am not going into that detail. Just I am trying to make you make you feel what is thermal stress. So a stress is proportional to a strain within elastic limit. That elastic limit will be taught to you in detail in the elasticity section. So here we obtain a relation, a stress by a strain. So a stress by a strain is a constant, and this constant, in fact this is a constant, and this depends upon the nature of material. So what is it is being called? It has symbolically it is represented by Y, and it is known as Young's modulus. Young's modulus of elasticity. It is known as Young's modulus of elasticity. This is the symbol, and you should understand that it is the property of material. It depends upon nature of material. It depends upon nature of material. You cannot say that if a stress is more, then the Young's modulus will be more. You cannot say like this. This stress by strain is constant. For iron, it will have the value for iron. It will have the value for copper. It will have the value for other things. So it depends upon the nature of material. So with this background of stress and strain and Hooke's law, I would like to discuss with you few more parameters, few more things about thermal stress. Let us try to understand what is this thermal stress. So we should understand what is thermal stress. In order to get the thermal stress, if I take thermal, as I told you repeatedly, it is related with heat. So heat can also produce a stress, and that stress is known as thermal stress. So we should understand the thermal stress. Let us suppose that there is a fixed rigid support. This is a fixed rigid support, and here is a rod. If this is a rod and if it is heated, it will try to expand, but it is not going to expand because it is fixed. So when it is fixed, the stress will develop, and that stress is called thermal stress. Now you see, a stress by a strain, as I said, is Young's modulus, Y. Due to heat, a stress will be equals to Y into a strain. As from the definition of a strain, this Y delta L by L. And in heat, I have already discussed you that what is this heat? Delta L. Delta L is basically alpha L delta theta by L. So L will cancel, and you are getting Y into alpha into delta theta. This stress is your thermal stress. So you should remember this result as the standard result, that thermal stress is 1 by 2 into alpha into delta theta, where what is alpha? Alpha is the coefficient of linear expansion. Now let us do one example based on this one. Example, if I am taking, suppose that there is a rod. There is a rod. Its temperature is 100 degrees centigrade, and uniform cross-sectional area is there, that is A. Young's modulus is Y, and this rod is cooled. This rod is cooled to a temperature 30 degrees centigrade. When the rod is cooled to a temperature 30 degrees centigrade, naturally its length is going to decrease. Its length is going to decrease. The question says that what is the weight that you will be attaching here? W. Find the weight. Weight is how much so that it regains this length, original length. Find weight attached so that the rod attains its original length. Naturally, your answer, and here one thing is given, that coefficient of linear expansion is alpha. Naturally, your answer should be in terms of A, Y, alpha and this temperature. So how can we solve this question? In this question, this stress is equals to force by area. Area of cross section is given. This force is basically the weight. So weight is equals to area into stress. And what is that stress? That stress is your thermal stress. So this is A, Y, alpha, delta theta. What is this delta theta? Delta theta is 100 minus 30. So you are getting A, Y, alpha 100 minus 30. So ultimately 70 A, Y, alpha. This should be your answer. A number of questions can be framed by giving the different value of A, different value of Y and different value of alpha and different temperature range. So this is basically the commando concept that I have discussed with you, which will be helpful in getting a variety of problem solution using this concept. So different value of A, different value of Y, different value of alpha and different value of temperature range will give you different value of weight. So this should be clearly understood by. Now the final side effect or final application of linear expansion we have to understand in the meter scale. Fourth, that is final, is your meter scale. In the meter scale, if we are taking a metallic meter scale, suppose this is the rod, this is the scale, and here is the rod. So if we are getting a rod, this is a rod, and both are TC. TC means calibration temperature. Calibration temperature means that temperature on which this scale will give the correct reading. So on calibration temperature, what is the actual value, length of this rod that is being shown by this scale. So measured value, one is the measured value, and this measured value will be the true value of the rod. True value. What is the true value of the rod that will be measured by it? Now if the temperature changes, from this calibration temperature, it may be in the higher side or it may be in the lower side. If this temperature goes in the higher side, then what will happen? Suppose this rod is not expanding, only the scale is expanding. Then this value will shift to this position. And then the reading will be what? Reading will be less, because suppose this is 3 centimeter and it has gone here 3 centimeter after heating, then here it will 2 that will come. So its value will be less. So measured value will be less than the actual value if the temperature is increased. In second case, If the temperature is suppose decreased, here it is 3 value, then this 3 will shift to suppose here this point 3, this has shifted to this one, temperature decrease, so thermal contraction will take place and this will shift to this position, then this measured value will be more than the actual value of this rod. So these things can be understood very well, and this can be understood in a better way when I will use one example to explain this concept. So let us take an example to understand. One is the measured value, one is the true value. When the measured value will be greater, when the measured value, so measured value can be greater also and measured value can be less also than the true value. So that has to be understood, whether the length is expanding or whether the length is contracting according to the, this value is very small, but for theoretical point of view it is very important to understand this concept. And so we will use one question in order to understand the whole concept of a scale by solving one question. Now let us understand the meter scale problem. In meter scale problem, there is a steel scale which measures the length of a copper rod. So rod is of copper rod, and steel scale is there, and the length that it measures is 80 centimeter when both are at temperature 20 degrees centigrade. So this 20 degrees centigrade is your calibration temperature, TC, the calibration temperature of the scale. What would be the scale reading? You have to find the scale reading for the length of the rod, for rod only, when both are at temperature 40 degrees centigrade. Here alpha steel is given and alpha copper is given. What does it mean? It means that rod is also expanding and the scale is also expanding. Alpha steel is given. Now you see, copper rod alpha is more, steel rod steel scale alpha is less. That means copper rod will expand more and steel rod will expand less. So what we can understand, that certainly the reading should be greater than this. Certainly the reading should be greater than this. Why? Because copper will expand more. The copper rod will expand more. Now you see, what I mean to say here, that temperature has been changed from 20 to 40 degrees centigrade. So steel rod will also expand, steel scale will also expand and copper rod will also expand. Now you see, if we take the centimeter scale of the steel scale, centimeter, 1 centimeter of the steel scale, then you will, its length at 40 degrees centigrade will become 1. Here I am using the formula L is equals to L naught into 1 plus alpha delta T, delta theta. So 1, this value, 42, put the value, and you are getting 1.022 centimeter. That means due to temperature change, 1 centimeter will become 1.00022 centimeter. 1 centimeter of the scale will become this much. Now what happens to the rod which has got 80 centimeter? This 80 centimeter rod will become, at 40 degrees centigrade, 80 into 1 plus alpha of rod. So alpha of rod is how much? It is this much, and you are getting 80.000272 centimeter. Now try to understand. Rod has also expanded and scale has also expanded, and I want to measure the rod reading. So what? Now it is the 1 centimeter that will be measuring it. In terms of 1 centimeter, how many times the 1 centimeter is repeating itself? How can we find the how many times 1 centimeter is repeating itself? Just by dividing the result. So 80.0272 divided 1.022, this value, and this is your reading of the scale. That means scale is reading. Scale reading is this much. Now in this question, this can also be done that the rod is not expanding, then the value will be different. This can be also done that a scale is not expanding, only the rod is expanding, then also you can find. So varieties of question just by applying this concept of scale reading and this problem will make you capable in solving any problem of this profile. What I mean to say, if the rod is expanding, then also if the rod is expanding, then also you can get. If the scale is expanding, then also you can get. If both rod and scale are expanding, then also you have got. Here just now I have discussed. So this factor should be kept into mind. I hope that this much discussion of application of linear expansion in solving the varieties of problem will be helpful to you, and it will help you in making you confident, and you will develop a better concept if you will practice your learning and reading on this type of problem solving based concept. So thank you. Have a nice day.